Hello, I'm going to describe our project, testing low-cost, ultra-portable carbon dioxide and methane sensors for monitoring salt marsh ecosystem services, resilience, and restoration. Significant interest surrounds the function of salt marshes to sequester blue carbon. Research shows that salt marshes sequester more carbon per unit area than any terrestrial ecosystem. However, planning for climate change resiliency and restoring marshes with the goal of blue carbon sequestration is impaired by the large uncertainty of greenhouse gas fluxes in marshes. Here we focus on the limited data of vertical fluxes between the marsh and the atmosphere. Marshes can oscillate between being a source or a sink of carbon dioxide. Also, more data is needed about methane, an important greenhouse gas with 96 times the global warming potential of carbon dioxide. We address the need for more monitoring of carbon dioxide fluxes in salt marshes. Current sampling efforts are logistically challenging, time-consuming, and/or cost prohibitive. Some can also be destructive to the marsh. This leads to a lack of data on spatial and temporal carbon dioxide fluxes. Yet, we anticipate that salt marshes are spatially and temporally heterogeneous across both large and small scales. Additionally, most sampling is done during the growing season. Yet, it has been hypothesized for over 3 decades that microbes within marshes may be active during the winter. And with warming winter temperatures and changes in precipitation, we anticipate that dormant season carbon dioxide fluxes could become important for the overall annual carbon budget. To help move our understanding of salt marsh carbon dioxide fluxes forward, we are developing low-cost portable instrumentation. The sensor package can measure carbon dioxide temperature and humidity. We are also testing a methane sensor to see if it can be included in the sensor package. This NOAA Catalyst project is working with the New England NERRS to develop best practices for deployment and integrates design ideas from end users to increase ease and efficiency. Our ultimate goal is to develop a carbon dioxide monitoring protocol that can be easily used alongside existing monitoring efforts, such as vegetation monitoring. We are using an iterative methods of design, development, and feedback. We have already conducted one round of design, followed by end-user field deployment, and then feedback from the users about the sensors and field deployment process. Now we are incorporating the end-user's feedback. Then we will go through this process of design, deployment, and feedback again. This project is a collaboration with the research reserves throughout New England to increase the monitoring of carbon dioxide and methane fluxes in this region. We had a remote kickoff meeting in November with representatives of the 5 reserves: Wells, Great Bay, Waquoit Bay, Narragansett Bay, and Connecticut. We are interested in investigating temperature gradients across this region and testing the sensors in nearby sites. We deployed the sensors in December at the 5 reserves. Collaborative leads at each reserve joined for the field training in deploying the sensors. Conversations in the field were a first step of feedback about the process. We also shared a follow-up survey to record reactions to the field deployment and design ideas for the sensors. Products of this project will include the sensor package and associated materials to measure carbon dioxide and methane in salt marshes. Also, we will write a monitoring protocol using the sensors. Finally, we will share the data from wintertime sampling and a major sampling effort during June to September to align with vegetation monitoring efforts during the summer. The sensor package and monitoring data will be a tool to increase our understanding of blue carbon sequestration in salt marshes. This carbon flux data can be used to answer many questions about climate change impacts and restoration goals surrounding carbon sequestration, including new questions into the future.